Amines. Okay, another organic family that we need to know about are the amines. The amines have this functional group, the amino group. Okay, it's an NH2, or just a nitrogen, we'll see, that links other carbon chains together. Okay, so anytime you see, I don't know how often I've used this this notation, but anytime you see an R group like this, it just means some carbon chain. All right, so let's name a few amines. So let's just say we've got the standard, what we would call a primary amine. Again, a primary amine, similar to halogenoalkanes or to alcohols. It's a primary amine because now we are looking at the nitrogen in this case, and the nitrogen only connects to one other carbon here. And of course I've been lazy and not included all the hydrogens that would be there. All right, but the nature of that nitrogen only connecting to one carbon means it's a primary nitrogen, so this would be called a primary amine. And the name of this amine, as you can see, the longest run of carbons is 4, so it's a bute. So this would be called butanamine. And it's that simple, you just put amine as a suffix, and that's how you name these. So how about this one? We see something a little bit different with the structure. This is what we would call a secondary amine. And hopefully you're seeing the pattern that here, the nitrogen, is actually connecting to 2 other carbons, so it's a secondary nitrogen. And what would we name this one? Well, the longest run of carbons is prop. It's 3. So this would be a propanamine. Propanamine. And then how do we then indicate the presence of this group up here? Well, we treat it like a substituent. Okay, and we say this substituent is connected at position N. So this would be N-methyl propanamine. One more note about amines. Amines, are they polar or non-polar? Let's just take this little guy right here and try to analyze it. Is that going to be, this is ethanamine. Ethanamine. Polar or non-polar? Well, the answer is that it's polar. It's going to have this amino functional group on one end, and one way or the other, you're going to end up with, if you were to draw the whole structure out with a little bit more detail, which I maybe should have, you're going to end up seeing that you're going to have around this nitrogen, there would also be a lone pair. You're going to end up with kind of a trigonal pyramidal structure around this nitrogen. Hopefully you remember your kind of shapes. So you're going to end up with a partial negative charge on that nitrogen, a partial positive charge on these. Anyways, believe me, the whole thing's going to be polar. The other interesting thing with amines is that they have hydrogen bonding capability, right? If you recall what you learned about intermolecular forces, you could possibly make hydrogen bonds at these 2 hydrogen positions because they are hydrogens covalently bonded to a nitrogen. Remember, any hydrogen covalently bonded to a nitrogen, an oxygen, or a fluorine has the potential to interact with neighboring molecules via hydrogen bonding. So, most importantly, these can hydrogen bond with water. So amines, small amines, if they get too large, this won't be true, but small amines are water soluble, as they are polar molecules, and they also have hydrogen bonding capability. So small ones are water soluble, and then it would follow all the regular rules that you might expect with a homologous series if you make them larger, as in the larger ones will have higher boiling and melting points. They stick together more because of London dispersion forces. So just maybe interesting to note they're water soluble, and they do have hydrogen bonding capabilities. So how about a tertiary? So can there be tertiary amines? Yes, there can. Nitrogen can make 3 bonds. So it can be bonded to, a couple carbon groups on the side over here, and then a couple here. And of course the longest run is going to be 2. So this is going to be an ethanamine. Ooh, don't know if I left myself enough space to write the whole name, but let's hope I did. This is now a tertiary nitrogen, and so thus it's a tertiary amine. This would be called, with a methyl group there and a methyl group there, it would be called NN, since they're both attached to the nitrogen, NN dimethyl, can he squeeze it in? Yeah. NN dimethyl ethanamine. Okay, let's try another one. Let's see, what if we do something like this? Just riffing away. That's going to be the end of that. Okay, what is this? Is this a propanamine or is it an ethanamine? Well, as usual, you go with the longest run. So the longest run's 3, so it's going to be a propanamine. Propanamine. And then the substituent is now a 2-carbon substituent, so that's an ethyl group. It is connected to the nitrogen, so it is an N-ethyl propanamine. That could all be one word there. Ooh, finally, is this a primary, a secondary, or a tertiary amine? The answer is, it's a secondary. Notice this nitrogen is connected to 2 carbons.